Okay, let's take a look at number 6 that we were doing in class today. So it says a skydiver leaves a plane at an altitude of 3,000 meters and falls freely for the first 6 seconds. So before the parachute opens, we have a VI of 0. We have a delta T of 6 seconds. And it says, because of air resistance, the diver experiences an acceleration of only 8 meters per second squared, so not 9.81. And of course that's going down. As the parachute fills with air, so now we're in the second part while it's opening. As the parachute fills with air, the diver is slowed down to 5 meters per second in 10 seconds. So the 5 meters per second is going to be the V final. And the time is 10 seconds. And the V initial is whatever the V final was up here. So whatever the V final is in the first part, it becomes the V initial of the second part. Then, if the diver continues to fall at this speed for the rest of the dive, so now it's after we've opened, and at this speed means the final speed of the second part, so it's going to become a VA for the third part, of 5 meters per second. How long will it take for the diver to reach the ground? So we need the delta T of all 3 sections. So in the last part, to get the delta T, we need the delta D. Here we have the time, but we don't have the delta D. It doesn't ask that, but we need it to get the delta D of the first part. Okay. So, if we go back to the beginning, then, there's one more thing. It says this whole distance is 3,000 meters. Okay? So remember that we need to get all the times, and in the third part, to get the time, we need the delta D3. So if we can get the delta D1, and we can get the delta D2, then with our 3,000 meters, we can get our delta D3. So in going back to the first part then, the 2 things we don't have are VF or delta D, number 1. So if we look at our givens, we have VI, A, and delta T, so we can get our VF using A equals VF minus VI over delta T. The VI is 0, so VF is just equal to A delta T. So the VF is equal to A is 8 meters per second squared, and delta T is 6 seconds. So the VF in the first part is 42, make that 48 meters per second. That becomes the VI in the next part. All right, then we need our delta D. We have VI, A, and delta T. So delta D is equal to VI delta T, 1/2 A delta T squared, and the VI goes to 0. So delta D is equal to 1/2 A is 8 meters per second squared again, and T is 6 seconds. So 6 squared, 36. Half of 8 is 4. 4 times 36, that's like 12 times 12. So it's 144 meters. So that's our delta D1. All right, we're now ready to move to our second part. So we have our VI, we have our VF, we have our T, we need our delta D2. So first we can find A. So A will equal VF minus VI over delta T. So it'll be equal to 5 meters per second minus 48 meters per second over 10 seconds, negative 43, negative 4.3 meters per second squared, where of course the negative means slowing down or acting up. So once we have that, we can get our delta D2. So you could use either VI, and that's what I'd probably do. So delta D2 is equal to VI delta T, 1/2 A delta T squared. So delta D2 is equal to, so the VI was 48 meters per second. The time is 10 seconds. Plus 1/2 negative 4.3 meters per second squared, and the time 10 seconds squared again. So our first term, 480 meters, minus 10 squared is 100. 100 times 4.3 is 430. Take half of it, 215 meters. So delta D2 is going to be 265 meters. So now that we have our D1 and we have our D2, we can find our D3. So delta D3 should be equal to the 3,000 meters minus the delta D1 plus delta D2. So 144 and 265, so 300, 409 maybe? Is that what that is? 144, 265. Yeah, 409. We're taking that away from 3,000. So delta D3 is equal to 2,591. I think. You're not here to tell me that I'm doing it wrong. So what was it? I don't even remember now. 491, and we're adding that to 3,000. Oh, I don't know what it was. Now I screwed it up. 144 plus 265 plus 3,000. I got it right. Put a meter on. Okay? So now that we know that, now we can find our T3 by doing VAV is equal to delta D over delta T. So delta T3 is equal to delta D3 over VAV. So delta T3 is equal to 2,591 meters divided by 5 meters per second. And you get 518.2 seconds. And so now to get our total time, 518.2 plus 10, plus 6. So 518, 528, 534.2. So delta T total, T1 plus T2 plus T3. Total should be 24.2 seconds. Done. It's the only thing it asked. How long? And there it is. And look at that. It even agrees with the answer. Alright, let's switch to the next one on the back. Number 1. Car and a motorcycle at rest, 100 meters apart, start towards each other at the same time on a level track. Car accelerates at a uniform rate of 3.7 meters per second squared. Motorcycle at 4.4 meters per second squared. At what position will they pass each other with, or meet each other with respect to the car? Okay, so 2 parts. Car, motorcycle. It says that they start towards each other, so VI is 0 and VI is 0. It says the car accelerates at a rate of 3.7 meters per second squared, and the motorcycle accelerates at a rate of 4.4 meters per second squared. It says they're 1,000 meters apart. So what that means is that delta D of the car plus the delta D of the motorcycle should equal 1,000 meters. So what would the delta D of the car look like? It would be delta D is equal to VI delta T, 1/2 A of the car, delta T squared. VI goes to 0, so delta D of the car is going to be 1/2 A of the car, delta T squared. For the motorcycle, same equation. VI delta T goes to 0 again.